live captions. That gun, Mr. Shirley's sitting in the field. He's all al fresco today. Looks like he's sitting in a wheat field or something. Or is that just a wall behind you? Oh, he's at the Student Center. Correct, Pendleton campus? I think he's at the Student Center.
Yes, sir. Student Center.
Okay. All right. So here we go. Here is, it's working better now. Hopefully it's good now. Good. All right. Always reboot. Let's go to our handy dandy. Looks like we've got 4 questions and 1.2. This is 1.2, number 11. And let's see what this question is. First of all, is it a test question that I would put on my test for y'all? Wait a minute. This is, let me pull that back up. That's 109. That's not y'all. There we go. All right. 9.111/2. 9.111/2. Find the complementary and supplementary angles. Okay, first of all, this is a question. It is a test question, unfortunately. I have to put it on the test because guess what? This is also a standardized test question. So I have to put it on my test. So you have to think of, let's go back to our handy dandy unit circle. And if you don't know it, you're gonna know it soon. This is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360. Capiche? Okay, if you change those to radians, this is 0 radians. This is pi over 2 radians. This is pi radians. This is 3 pi over 2 radians. And this is 2 pi. Everybody with me? So 90 degrees is pi over 2. 180 is pi. 3 pi over 2 is 270, and 2 pi is 360. Somebody give me a nod. Okay, y'all got that? So, complementary angle is here. Supplementary angle is here. If we were talking about degrees, you would use 90 and 180. But since we're talking about radians, you're not going to use 180 and 90. You're going to use what? Pi over 2 and pi. Now you should be able to put it together. So let's put it together. Let's take our handy dandy question. And it says, find the complementary and supplementary angles to 2 pi over 5. Okay, 2 pi over 5. So what do we need to do? Well, you could, if you wanted to know what 2 pi over 5 was, you could also do this. 2 pi over 5 is equal to 180 over pi. Sorry. This is how you go from radians to degrees. Will 5 go into 180? Yes. 16 times, wouldn't it? 5 or 30. Say 5 will go into 18 3 times. That's 15 and 30, 36. So that will go in there 1 time, go in there 36 times. 36 times 2 is 70 what? So 2 pi over 5 is really what? 72 degrees, Hubert. So 72 degrees to 90 degrees. What's this angle? 30 or 20 what? 28 degrees. And 72 degrees here. What's this angle? Oops, sorry. 72 degrees here. What's this angle? Well, 180 minus 72 is what? 180 minus 72 is what? 108? Now that's how you do it with degrees. But how do you do it with those fractions? Well, you do it the same way now. Now that you know how to do it, you do it the same way. Instead, this is pi over 2, and this is pi. So let's go back and let's draw it. I'm running out of black pen. I'm covered though. I got my Amazon. I buy everything Amazon, so everything comes in boxes. So here we go. There's our supplementary angle. And this angle right here is 2 pi over what? 2 pi over 5. And this is pi over 2. All right, now I want you to put this in an equation. Blank plus blank is equal to pi over 2. So what plus what? X plus what? 2 pi over 5 is equal to pi over 2. That's the same thing as saying X plus, what was it, 72 is equal to 90. Everybody with me? Okay, now do this. Oh yeah, that's right. Y'all can't do fractions, right? Half of you won't even do it. So I'm going to subtract 2 pi over 5. I got to get a common denominator. So X is equal to blank 10 minus blank 10. 2 will go into 10 5 times. 5 times pi is 5 pi. 5 will go into 10 2 times. 2 times 4 pi is, 2 times 2 pi is 4 pi. And X is equal to pi over 10. And something is not right. That's a little bit better. There we go. So let's check it. Pi over 10. Pi over 10. And we feel good about ourselves. So we don't have to put on too much makeup and have an orange face and a white neck. All right, now you do that one. And don't worry, don't stress. If you can't do it, we'll just consider you a failure. And we'll put a failure emoji right there on your square. This thing got a failure emoji, loser emoji. We'll have to create one.
I'm gonna make myself a failure hat and
There
wear it
you
to class
go.
every day.
There you go. That's the kind of attitude we need.
Absolutely.
Everybody gets a trophy. Y'all are doing really well. Y'all are already on the trig homework. Y'all are doing good. I know one thing, if they don't call about my truck today, okay, you need to mute. Somebody needs to mute. Somebody needs to mute their Miss Croxton. I think you need to mute.
I was transferring, sorry.
Woo! Woo doggies. All right. Now, what was I saying? That they better have my truck ready today. I've gone all week without my truck. And for some of y'all, I don't know what that means, but for me, my truck is like my office. So, and it's red and black, and Georgia plays this weekend, so oh, forget it. They're gonna blow it. They're gonna choke.
I was about to say, y'all play us. Y'all aren't going to win.
I'm sorry, Mr. Shirley. What'd you say?
I was going to say, y'all play Clemson, so you're not going to win.
Yeah. Well, it all depends on if the referees, if we pay them off, because whenever Clemson loses, it's the referee's fault.
Well, see, we don't lose much, so.
Are you a Clemson fan, or wait a minute? Are you a Clemson supporter? Or are you a Clemson fanatic?
Fanatic.
Okay, well, I don't, those people turn me, no offense, Mr. Shirley, but.
Oh, I get it.
Them people are crazy. I'm sorry, you're not crazy, but they are.
When it comes to football, I am.
I actually saw a fight break out on the extra, I want to call extra, it's not extramarital, sorry.
Intramural?
Thank you. Field. There was a fight between two groups of people, and you know what it was over? A rubber chicken. It was during the South Carolina Clemson game, and it was over a rubber chicken. You know what? People need something to do. I'm sorry. I'm not a worshiper of athletics, and I guess I just don't understand. I just don't understand that. And you know, I'm a supporter. I got 3 degrees from Clemson. I've got to give to the foundation. I give to IPTAY. But do you know why I don't go to Clemson games? Because of the Clemson fanatics. That's why I don't go. I can't handle it.
Yeah, I get it. We're
So
not fun.
if you get yourself thrown in jail for that, Mr. Shirley, I can't respect that. I can't. I'm sorry.
I don't think I'm that crazy.
Okay, good. Thank you. If you call your firstborn Clemson, I don't want to speak to you. Okay. There are people that do that. There are people that paint their house orange. Okay.
Yeah, that's a bit.
You're
much
with
for
me?
Yes, sir.
Okay. So here we go. But Georgia, Atlanta Braves, Atlanta Falcons, they all have one thing in common. They always choke. Georgia does have a good team this year. They are loaded. They got a lot of seniors, but I don't know. They always blow it. I love my dogs, but they always blow it.
How do you feel about
Should be a good game.
What'd you say?
How do you feel about the Falcons losing the 28-3 lead?
I have no idea what goes on with the Falcons in their head sometimes.
See, I'm a Patriots fan, so I had to bring it up.
I love my Falcons I love Falcons. I love them. But there's something about Atlanta, Georgia, and Athens, Georgia, that we're going to blow it, and they do it every year. So I'm just used to it. So I watched some of that game, but I didn't watch all of it because I'm not a fan of the NFL at all. So I try not to get I'm not a fan. All right, here we go. we got an angle going over this way, and we know this is pi, and this is 0, and we know the angle they're giving us is 2 pi over, I don't forget it, 2 pi over 5.
Yes.
So this is 2 pi over 5, and this is x. So x plus 2 pi over 5 is equal to pi. Minus 2 pi over 5. Minus 2 pi over 5. And this is pi over 1. So we got to have a common denominator. So that's a 5. And that's a 5. And 1 will go into 5 pi. And 5 will go in there 1 time, 2 pi. So our answer is 3 pi over 5. And hopefully showing you this, kind of got you, you know, that's pi over 2 and that's pi. So you do it the same way, you just change 90 into pi over 2 and you change 180 into pi. Do we feel good about ourselves? 3 pi over 5, let's see. 3 pi over 5. 3 pi over 5. Yay! That's a test question. And you will also have a complementary and supplementary with degrees. Next. And that takes care of that. Does that help? Mr. Ramey, does that help? Next is 9-1. Now, 2 of you have sent this problem. So it's either a yucky problem or we haven't went over it yet, one of the 2. So this says at 9.1, 115, 30. And, okay, we have not covered this yet, but we will cover it. So this is a good one to start class with today. Okay, but first of all, I need to go back and show you the last part of 9.1 before we finish, here we go. So main menu, my courses, Math 111. Come on, Math 111, where are you? Math 111. E-Text 9.1, and this is radians and curve length. So okay, come on, anytime. And 9.1. And get rid of this. And we talked about that. We talked about that. Talked about that. Talked about the quadrants. I'm not really worried about that. Now, let's talk about coterminal. Let's talk about that. 908 degrees. 908 degrees. We know, mute your mic, somebody. We hear you breathing, okay? All right. Let's go with 908 degrees. Now, do we need these in real life? No. Nobody will walk up to you in any job and ask you to turn 908 degrees. This is just academic. I really don't test. I might give you one question like this on a test, but that's just because it's on a standardized test. Okay? And if you have questions, send it to me through Ask My Instructor. All right, so we know that this is 360 degrees. Everybody with me? So the first thing you do when you're talking about one of these problems is find out how many 360s will go into this. Because you got to find out how many revolutions you got. All right? So 360 plus 360 is 720. So we're going to subtract 720 because 360 times 3 is 1,080, and that's 2 what? 1,080 is 2 what? It's too much. So I can't do 1,080. So I got to subtract 720 from 908. 8, 10, 8, and 8 minus 7 is 1. So we're really finding 188 degrees. So if you turn your angle, if you turn it 360 degrees, then you go 720 degrees, that's 2 revolutions. The actual angle you are finding, no sneezing in class.
Sorry.
The actual angle you're finding is what? Let's see, 180 is right here. So the actual angle you're finding is 188. Capiche? Did everybody understand? So when you're trying to find a coterminal angle, coterminal means the real angle. Basically, what's the real angle? The real angle is the green, because these revolutions don't mean anything as far as trigonometry, as far as the trig functions. I'm going to find the trig functions for the 188 degrees. And 188 degrees could also be, let's see, 1,000, what did I say, 1,000, what's 360? 1,080 plus 188? 8, 6, 2, 1. I could ask you, what is the coterminal angle of 1268 degrees? It's still 188. Because all I did was add 1 revolution to it. The revolutions mean nothing. On coterminal, the revolutions mean nothing. You got it? So if I gave you, what's the other one they gave us? Okay, negative 180. Or, I'm sorry, negative. When you see a negative angle, that means you're going in the other direction. So negative 800. Negative 360. Negative 720. So what am I going to do? I'm going to take negative, I'm going to take 800, and I'm going to subtract what? 720, and what I get? 80 degrees. So the actual angle that we're looking for, this is 90 degrees, so negative 80 degrees. That's the angle we're looking for. And these pins are shot. Question. That's 2 test questions I could give you with those, a negative and a positive. Okay, did you send me those questions yet? If you got questions, somebody sent me, said they have a question on 21. Let me look and see if they sent them. Don't see them yet. So you don't need to delete these. Okay, well, I haven't got to this yet. So I'll wait until somebody sends them. All right, so what's next in our okay, what's next? Radians. Okay, here we go. Radians. That's a radian right there. A curve that matches. What is a radian? A radian is the curve measurement that matches the radius. A radian is a curve, the curve, because there's only one part of the circle that's a curve, and that's the curve part. The curve measurement that's equal to the radius. The curve measurement that's equal to the radius. Well, I'm going to give you an example of what I'm talking about. Here's a circle. This radius, let's say this radius is 4. So that means this radius is 4. Okay? This is going to be larger, this curve right here is going to be larger or smaller than 4. This curve is going to be greater than 4. The curve is always longer than the chord. That's the chord. And the chord is the hypotenuse. The hypotenuse is always the longest what?
Side.
The longest side, Hubert. That's right, class. Thank you. So this is the chord, which is equal to the hypotenuse. And the chord is always the longest side. So what can logic dictate about the curve if the hypotenuse is always the longest side? The curve is always going to be the what? It's always going to be the longest. So what is a radian? A radian is when you have this setup right here, 4, 4, and this measurement right here is equal to 4. So that means that this is not going to be 90 degrees. You see that? That's the kicker. The radian is not 90 degrees. If this is equal to 4, this is equal to this is equal to this. This cannot be 90 degrees. Everybody with me? Okay, because if it was 90 degrees, this would be the longest side, therefore this would not equal 4. So this is a radian. It is a unit, basically. I would say a unit of measurement, but it's actually a unit of revolution measurement. Because this is 0 radians. This is pi over 2 radians. This is pi radians. This is 3 pi, what did I say, 3 pi over 2? I always get it mixed up. Radians. And this is 2 pi radians. 1 revolution is equal to 2 pi radians. 1 revolution is equal to 2 pi radians. Yes, right, that's right. The curve is always the longest. And that's what they're going into with your second part right here. And these are very important. Because one of the tricks of trig, Hubert's trick of trig, always know where you are. Did y'all see on this problem a while ago? This homework problem. I looked at it from a student's perspective. This problem right here. Do y'all remember this problem? I said it was 2 pi over 5. What's the first thing that comes to your mind when you see 2 pi over 5? What the hell is that? Right? What did you see me do when I looked at that? What did I do exactly? I changed it into what?
Degrees.
So I would know where I was. And I found out that I was at 72 degrees. Does everybody understand what I'm talking about? Find out where you are. I changed it into degrees to find out where I was. Does that happen a lot? Yes. Sometimes you need to find out where you are so you know where you're going. That was deep, wasn't it? That was profound. All right. So what does that mean? That means you got to be able to change from degrees to radians and from radians to degrees. If you're given 75 degrees, put it over 1. You got to have degrees cancel. So that's pi over 180. How did you know that, Hubert? Because you got to have pi's. What has to degree? What if you're wanting radians? You got to have pi in your answer, and what has to cancel? Degrees has to cancel because you're wanting pi. So 180 goes on the bottom. And if you're given radians, 4 pi radians, put it over 1. What do you multiply by? 180 over what?
Pi.
Because what do you have to get to cancel?
The radians.
You got to get the radians to cancel. If I had been shown that when I was in algebra and trig, do you know how much better I would have done? I was never shown that relationship. I was just told to multiply by pi over 180, 180 over pi. Wasn't given any explanation. Yes, I remember the bad stuff. Yes, I do. In order to get the degrees to cancel, you have to put 180 on the bottom. In order to get the radians to cancel, you got to put the radians on the bottom. If somebody had explained that to me, it would have made a whole lot more sense to me back in trig. Okay? Radians to degrees or degrees to radians, so it is the conversion method you utilize to know the property. Yes. Yes. Okay? So make sure you can do this, because this is true. Sometimes you're going to be given radians and you're going to say, what the heck does that mean? Change it into degrees so you'll know where you are so you can draw it better. Always do that. Okay? This is actually, yeah. When I was doing 21 and 23, I was very stuck. Struck? Okay. It's not. Oh, you got to remember, the only way that you can cancel is diagonally and vertically with fractions. And since you're multiplying, you've got to go diagonally. And you don't have to remember pi over 180 and 180 over pi. You just have to remember which ones to put on the bottom. All right, let's move on. I did that twice for you already, so I'm not gonna give you another example. You can write one down if you want to. They'll probably give you an example here. Yeah, there's 145. I'll do 45. Okay, 45. 45 degrees over 1 multiplied by pi over 180. Again, there was no memorization there. I just put the 180 on the bottom. And I would use cancelization as much as possible. 5 will go into there 9 times. 5 will go into 18 3 times. That'll leave 6. 9 will go into 9 1 times. 9 will go into, so pi over 4. Do you know I've shown students that before and the trick about the degrees on the bottom, and they were able to do conversions and they never have been able to do that before? I was one of those students. Didn't have no idea what I was doing. Okay. And converting radians to degrees, that's fine. Next. And there's, we talked about that. Okay, unit circle. Go ahead, and I'm going to show you an easy way to do the unit circle. Here we go. Here's the easy way to do it. And I'm going to erase. I'm not even going to look at that. Did I memorize it? To this day, I have never memorized the unit circle. Never. Here's how you do it. You draw a BA circle. You divide it into 4 quadrants. Remember I told you 0, 90, 180, 270, 360. Now in trig, there's 3 special angles. Can anybody tell me what those 3 special angles are? Anybody? Anybody? The 3 special
Is it the
angles.
360 and 45?
30, 45, and 60. Those are your 3 special angles. So put those in there. 30, 45, and 60. Now watch this. This is a trick I learned in the war. Extend that 30 degrees there. And what's 180 plus 30? Extend the 45. What's 180 plus 45? And extend the 60. What's 180 plus 60? It's a miracle. How about, you know, this is 60 degrees right here, so that means this will be 30. What's 180 minus 30? What's 180 minus 45?
135.
It's a miracle. And what's 180 minus 60? And now extend those. What's 270 plus 30?
300.
What's 270 plus 45? And what's 270 plus 60? 330. Microphone, please. Okay? Don't forget your microphone. Somebody's breathing. Okay? Now, how do you do? Well, I've already showed you how to convert from degrees to radians. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. So 30 over 1 multiplied by pi over 180. So pi over 6. 45 over 1 multiplied by pi over 180. And how many times will 45 go in there? Dang old 4, pi over 4. 60 over 1 times pi over 180. Well, heck, that's pi over 3. And some of y'all are going, oh my gosh. That's all there is to it. 120 over 1 multiplied by pi over 180. Knock the zeros out, you get what? Well, 6 will go in there. That's 2 pi over 3. Well, 135 over 1 multiplied by pi over 180. Okay, 5 will go in there. 5 will go in there 2. And that'll leave 7. 5 will go in there 3 and 6. I believe 3 will go into both of these. That'd be 9. That'd be 3 will go in there 12. 3 will go in there 3. That's 3 pi over 4. $150, 180 over pi, or pi over 180. 0 goes out. 15, 3 will go in there. Dang old what? 3 will go in there 5 pi over 6. And so on. So once you fill it out, then you can get familiar with it. But the whole point of me showing you this is you can do this right before a test. You don't have to memorize it. All you gotta do is just write it down and do it. And usually teachers will let you use a unit circle because, you know, the days of memorizing it, we don't memorize it anymore, but some teachers still do. I don't. I would much rather you learn how to build it than to memorize it because you can always build it. You can't forget building it unless you just forget 30, 65, and 60. If you forget those 3, then you might be on your way to Alzheimer's or something. Okay, because 30, 45, and 60, that's not hard to remember. And that's how you build the unit circle. All right, let's keep going. Because we're eventually going to get, there we go, arc length. Write that down. Well, it's probably on the next page. There it is. Arc length. S is equal to R, which is your radius, times your angle in radians. And we're going to do this problem right here. We're going to do both of these. So we got a circle, has a radius of 18.2 centimeters. And they want to know what is the length at 3 pi over 8. And what is the length of the arc at 144 degrees? Well, the thing is, you've got to make sure that theta is in radians. So we've got to change 144 into radians, right? So we got that in radians, so that's no problem. A is equal to 18, I'm sorry, arc length, I believe they call it S, is equal to R times theta in radians. So for A, that's going to be 18.2 times 3 pi over 8. Now for giggles, I'm going to change that into so I'll know where it is degree-wise. So 3 pi over 8 be 180 over pi. So 8, let's see, 4 or 2 will go in 8 4 times. 2 will go in there 90 times. 2 will go in there 2 times. 2 will go in there 45 times. And 45 times 3 is what? 45 times 3, 45 times 2 is 90. So that'd be 135 over 2. 135 over 2, which is equal to 67.5. 67 and 67 is 134, I believe. Yeah. So the first one is 60 to 60, almost 70 degrees. So it'll be somewhere in there, maybe. So they're wanting you to find, we'll do A in red. They're wanting you to find this distance right there. So that's 18.2 times 3 pi over 8. Are you going to use your calculator? Yeah, when you're doing arc length, nobody's going to walk up to you in a building construction site, and say, you know, I need a length of 3 pi over 6. Nobody's going to ask you that. They're going to say, what is the length of this curve? And you got to give it to them in decimals. So take your handy dandy calculator. And we're going to take 3 pi over 8, 3 second pi divided by 8 equals, and let's see, 3 times 3 is 9. Yeah, that'd be right. And we're going to multiply that by 18.2. I'm going to write it out because I don't know what they want us to round to. 21.44136986. Let's see what the directions say. Find the length. Doesn't say. I would assume since the 2 and the 0 is to the 100th, I'm going to go to the 100th. So 21.44 centimeters. And let's see what they got. Look there. It's a miracle. They got 21.44 centimeters. All right, now I want you to do 144. You got to change 144 into radians. And if you can't do it, then we all know what that means. Oh, I'm yawning. Sorry. All right, so 144 over 1 times pi over 180. And that's going to, let's see, 2 will go in there 72 times. 2 will go in there 90 times. 2 will go in there 36. 2 will go in there 45. 3 will go in there 12. 3 will go in there 15. 3 will go in there 4. 3 will go in there 5. 4 pi over 5. Somebody check my math, please. Okay, so B S is equal to 18.2 multiplied by 4 pi over 5. Now let's see. 144 degrees. Where is 144 degrees? 144 degrees. There's 180, so be just about half of that right there. Which is, let's see, this is 21, and this looks like the same as that. So I'm going to say it's going to be, just by using common sense, 42 to 45 centimeters. I could be wrong, but let's see what happens. Let's take our handy dandy calculator and let's do 4. I'm going to put parentheses around my 4 pi. 4 pi divided by 5 times 18.2. 45 point, isn't it a miracle? 45.74. And what did I tell you is going to be around? 42 to 45 centimeters. That's where your common sense comes in. Now, whoever sent that question, now you've got the arc length that you can find now. But let's go ahead and take it one step further. And that one step further is, let's see, I think, yeah, area of a sector, which is the area of this triangle right here. So write this down. The area, since it's a triangle, 1/2 base times height. That's where the 1/2 comes from. 1/2 base times height, in this case, r squared theta, and theta has to be in radians. So let's do this. Here's the question. Show a field, shows the field is shaped blah, blah, blah. Find the area of the field. Here's the field right here. So we've got a field that is, looks like a Christmas tree. It's got a curve. The radius is 321 meters, and the angle is 15 degrees. And our area is equal to 1/2 r squared theta. And theta is in radians. So the first thing I'm going to do is change 15 into radians. And there goes that. And the 15, I know 3 will go in there 5 times. 3 will go into 18 5 times. 3 will, no, let's see, 6 times, sorry. And 0. So 5 will go in 1 time. 5 will go in here 1 time, 2. So I get pi over 12. Somebody check me, please. Yes or no? Okay, now just do the math. I've got to open up a new black pen. So area is equal to 1/2. R is 321 squared times power of 12, which will give me A is equal to 321 squared times pi over 24. So take your handy dandy calculator and go 321 squared times pi and divide that by 24. So 13,488 square meters. 13,488.04 square meters. And that should be it for, yeah, that's it. 13.5, they rounded up. It does say probably round up somewhere. So they rounded up 13.5. Actually, it doesn't say round up. They just did. That's it. Now, I don't have enough time to go into that homework question, so I'm going to leave it on there, and we'll go over it Tuesday at the beginning of the class. I'm trying to find it. And there's the question right there. And now you should be able to do the question if I can pull it up. For some reason, it's not pulling up. Well, I thought it was going to pull up and it didn't. Okay. Well, we'll go ahead and just forget it today and I'll leave it in there. I've already called the roll, so y'all have a good weekend and work on 9.1, get it done, or have more questions sent to me, okay? Y'all have a wonderful weekend. Keep it between the ditches.
All right.
See ya.